Okay, so this is second lecture on laws of motion, and in today's lecture we will predominantly focus on the free body diagrams. All right, so let's see an application of free body diagrams. So that is the dynamics of uniform circular motion. Okay, so let's suppose we have a car. It is moving along this curved road and it is horizontal curved road. So in this case, what is the maximum velocity of this car? So maximum possible velocity with which you can drive the car safely is given by this formula. It is square root of mu s into r into g. Okay. And if you bank that road, why do you need banking of road? It's because you cannot rely on this static friction to provide for the necessary centripetal force. So you bank a road. So on a banked road, what happens? The maximum velocity with which you can drive the car safely, it is given by this formula. Okay, what is banking? It is raising of one edge of the road with respect to the other edge with some angle. Okay, by some angle. So here the angle is theta. Then Vmax is given by square root of Rg multiplied by mu s plus tan theta divided by 1 minus mu s tan theta. Okay, this is the formula. So we are not going to see the derivation. Okay, we have seen this in 11th standard. So this is the formula that comes out. Okay, after lengthy derivation. Then if there is no friction at all, then what will happen? So if there is no friction, then the maximum velocity is given by this formula. It is square root of, okay, there is one mistake in this formula. It is square root of Rg tan theta, not mu s tan theta. Okay. All right. Then let's move on to the problems. Let's solve some problems based upon the free body diagrams. And first problem is a block of mass 10 kg is in contact against the inner wall of a hollow cylindrical drum of radius 1. Okay, so there is a block whose mass is 10 kg and it is in contact with the inner wall of hollow cylindrical drum. Okay, the coefficient of friction between the block and the inner wall of the cylinder is 0.1. Coefficient of friction is 0.1. The minimum angular velocity needed for the cylinder to keep the block stationary when the cylinder is vertical and rotating about the axis will be. So we have a cylinder like this. Okay, and this cylinder rotates about this axis. Okay, and we have a block over here. Okay, so when the cylinder rotates, the block will perform circular motion. Okay, and the question is the minimum angular velocity needed for the cylinder to keep the block stationary. So why would the block be stationary if the cylinder is rotating? Because the block will also move in a circle, okay, as cylinder rotates, and there will be some centripetal force which will be provided by the normal reaction. Okay, so this is normal reaction. Okay, and then there is some friction between this block and the surface of the cylinder, so that friction will not allow the block to fall down. Okay, so now we have to find out how much should be this normal reaction. Okay, so normal reaction in this case is directed along the radius and towards the center. So with what speed? So it provides what? Centripetal force. So FCP equals to, I can write, it is the normal reaction, right? And normal reaction is equal to FCP, and FCP can be written as what? mr omega square. So we have to find out this angular speed, angular velocity. With what minimum angular velocity it has to be rotated. Okay, so then mr omega square equals to n, and now there will be some frictional force which is directed upwards. Okay, it will resist the fall of this block. So if it has to hold the block, at the same position, then the frictional force must be what? It should be greater than or equal to the gravity. Okay, force due to the gravity. So frictional force should be greater than or equal to force due to gravity, which is mg. And then what we can do is we can substitute frictional force equals to what? What is the maximum value of the frictional force? It is Fs, we know it is mu s times the normal reaction. Okay, so mu s times normal reaction, it is greater than or equal to mg, and we have found here the normal reaction would provide for the centripetal force. So we can substitute n equals to mr omega square in this formula. So we get mu s times mr omega square should be greater than or equal to mg, and then this m and m gets cancelled out, and we can take what? Mu s and r on the other side, because we want to find out what? We want to find out the angular velocity. Okay, so let's take mu s and r on the other side. So we get omega square is greater than or equal to what? G divided by mu s times r, and now we can substitute the values. So what are the values? So values are the coefficient of static friction is 0.1, g is 10, radius is 1. Okay, so let's substitute the values. So omega square is greater than or equal to what? G is 10, coefficient of static friction is 0.1, r is equal to 1. Okay, 10 divided by 0.1 will give us what? It will give us 100. So that is omega square should be greater than or equal to 100. That means omega should be greater than or equal to what? 10 radians per second. So this is the answer. Okay, so option, okay, we want to find out angular velocity and it should be greater than 10 radians per second. So it is option D, right? So is it clear? Yes. Okay, so let's move on to the next problem. So next problem is one end of string of length L is connected to a particle of mass m and the other end is connected to a small peg, okay, on a smooth horizontal table. It is a smooth horizontal table, that means there is no friction. If the particle moves in a circle with speed v, the net force on the particle directed towards the center will be. So what will be the net force on the particle? So we have a string whose one end is connected, the length of string is L, one end is connected to particle of mass m and another end is connected to a peg like this. Okay, and then it performs, the particle moves in a circle with speed v. Okay, it moves in a circle with speed v. All right, so question is, what will be net force on the particle? What will be net force on the particle? Okay, so what will be net force? So now you can say it is resting on a horizontal table. That means, so there will be weight of this particle mg acting downwards. Then there will be normal reaction due to the table which acts upwards. And since it is moving in horizontal plane only, there is no acceleration in vertical direction. So we can say n is equal to mg. So these two are balanced out. And tension in the string, it is directed along the radius and towards the center, and it provides the centripetal force. Okay, when it moves in the circle, it's the tension in the string which provides the centripetal force. Okay, so net force will be what? It's just equal to T. Okay, so net force acting on this particle is just equal to T. Is it clear? All right. So I guess so. Let's move on to the next problem. Next problem is a car is negotiating a curved road of radius r. Okay, so there is a car which is moving on a curved road and its radius is r. The road is banked at an angle theta. The road is banked at an angle theta. The coefficient of friction between tires of car and road is mu s. The maximum safe velocity on the road is, and I guess this is the direct formula. So check which of these is the answer. So square root of g into mu s plus tan theta upon, this is not the formula. Okay, it's not g upon r. It is, what is the formula? It is square root of rg multiplied by mu s plus tan theta divided by 1 minus mu s tan theta, and it matches with option D. So this is the answer. Okay, the direct formula. Okay, yeah. Let's move on to the next problem. Next problem is two stones of mass m and 2m are whirled in horizontal circles. So there are two stones. One has mass m, okay, other one has mass 2m, and they are whirled in horizontal circles. So now the heavier one is in radius r by 2. Okay, so radius of this one is r by 2, and lighter one in radius r. Lighter one is moved in radius r. The tangential speed of lighter stone is n times, okay, the value of heavier stone. The tangential speed of the lighter one, let's call it v suffix m, and it is the tangential speed for this one is suppose v times v suffix 2m. So it is, this thing is given that it is n times of v2m. All right, and then when they experience same centripetal forces, the value of n is, okay, it's given that the centripetal force experienced by both of them is equal. So we can solve this easily. So fcp for mass m is equal to fcp for mass 2m. Okay, we can write this. Then what is fcp? It is mv square divided by r. So it is m times vm square upon its radius is r. It's equal to fcp for 2m. So its mass is 2m multiplied by speed square. So v of 2m square divided by, what's the radius? Radius is r by 2. Okay, it's r by 2. Something gets cancelled? Yes, mass gets cancelled, radius gets cancelled. Okay, this 2 will go into the numerator. All right, so we get Vm square equals to 4 times of V of 2m square. Okay, and then we are given that Vm equals to n times 2m. So we found Vm square is 4 times V of 2m square. Okay, then that means what? Vm equals to 2 times of V of 2m. Speed of particle of mass m is equal to 2 times the speed of particle of mass 2m. So that means this n is equal to what? 2. Okay, n equals to 2, and option C is the answer. All right, so it is simple. Okay, clear? Yes. So let's move on to the next problem. Is there some delay? Maybe. Okay, let's move on to the next problem. A car of mass 1000 kg negotiates a banked curve of radius 90 meters on a frictionless road. If the banking angle is 45 degrees, the speed of the car is. This is the question. Okay. So the road is frictionless, that means mu s is equal to 0. So which formula for maximum speed do we have to use? It is square root of Rg into tan of theta. Okay. So let's substitute the values. This is straightforward question. So values are R is equal to 90, G equals to, let's suppose it is 10, and tan of theta is tan of 45 degrees. Okay, theta is given to be 45 degrees. So it is tan of 45 degrees, and tan 45 is 1. That means it is square root of 90. Sorry, it's 900. So square root of 900 is 30. Answer is 30 meters per second. Simple. Okay. Yes. So let's move on to next problem. Next problem is a gramophone record is revolving. Yeah, good morning, Dev. So next problem is a gramophone record is revolving with an angular velocity omega. A coin is placed at a distance r from the center of the record. So you might not have seen the gramophone record, or you might have seen it in movies. Okay. So gramophone record used to be disc. Okay. So earlier the audios were recorded on disc like this, and there was contact, okay, which used to play those audios, which used to take the signal from this disc, okay, to the speaker. All right. So you might have seen in the movies. So it's a disc basically for our purpose for this problem, and it's moving with velocity omega. It's the angular velocity omega. Okay, and we place a coin at distance r. So here is our coin. Okay, then from the center of the, so distance is r. Okay, then the static coefficient of friction is mu. The coin will revolve with the record if. Okay, so we have to find out the condition when this coin will revolve with the record, okay, with this disc. So now when it revolves, it will have tendency to slip off, right? So which force restricts the coin from slipping off, and it also provides centripetal force? It's the frictional force, right? So the frictional force, okay, which is mu s times the normal reaction, it should be greater than or equal to what? Should be greater than or equal to mr omega square. Okay, so mu s times normal reaction. So we have to find out normal reaction, and since the coin is resting on a horizontal plane, it's simple. So its weight acts downwards and normal reaction acts upwards. So normal reaction is just equal to what? The weight of the coin. Okay, so n is equal to mg in this case. So we can substitute that. So we get, so we get mu s into mg is greater than or equal to mr omega square. So m gets cancelled. All right, and so omega square we can take on other side. So we get the value of r. So r is less than or equal to what? Mu s times g divided by omega square. So check which formula. So mu s is mu over here. So r is less than or equal to mu times g over omega square. This should be the answer. Okay, option C. Okay, clear? There is one more option. No, it is reciprocal of that. So if you have an option like r is less than or mu times g or omega square. Okay, so this would be wrong in case this option is present, because it is less than or equal to not less than. Okay, yeah. So let's move on to the next problem. And the next problem is, a roller coaster is designed such that riders experience weightlessness. Okay, so you have a roller coaster ride where riders experience weightlessness as they go round the top of the hill, whose radius of curvature is 20 meters. Okay, so there is some roller coaster, something like this, and when you go top of this hill, okay, let's suppose you are here, so you experience weightlessness. So why do you experience weightlessness? Because there is no normal reaction. The normal reaction is equal to 0. Okay, so normal reaction acts upwards and your weight acts downwards, mg. So you will feel weightless if the normal reaction is 0. Okay, so for weightlessness, n should be equal to 0, and in that case, the speed of car at the top of hill is between. This is the question. What should be the speed of car so that you will feel weightless? Okay. So now here you are performing kind of circular motion. Okay. And for this circular motion, there will be some centripetal force needed, FCP, which is directed along the radius and towards the center. Okay. So you are going top of the hill. That means the centripetal force will be downwards. All right. So this downward centripetal force must be equal to what? Total downward force, which is weight, minus total upwards force. Okay. So it is mg minus the normal reaction, right? So normal reaction is equal to 0. That means FCP equals to mg only. Okay. And it is mv square or r equals to mg. M you can cancel out, so you get v square equals to, you can take r on the other side. Okay, so v square equals to rg, or v equals to what? Square root of rg, and that's equal to, you can substitute the value. So r is 20 meters. Okay, radius of curvature is what? It is 20 meters. Okay, so let's substitute that. So we get what? 20 times g is 10, close to 10. Okay, it's 9.8. So it will be square root of 200. And what is square root of 200? So square of 16 is 196. Okay, so this speed will be more than that, but less than 17 meters per second. Okay, so option A should be the answer. Okay, square root of 196 is 16, so square root of 200 will be little more than that, but it will be clearly less than what? Square root of 17. Sorry, it will be clearly less than 17 meters per second. Okay, so option A is the answer. All right, so let's see next problem. This was easy. Yeah, so two bodies of mass 4 kg, this first body has mass 4 kg and 6 kg, are tied to the ends of massless string. Okay, so we have two bodies tied to ends of massless string. The string passes over a pulley which is frictionless. It's given here. The acceleration of the system in terms of acceleration due to gravity g is, this is the question. So what we have to do is, we have to draw free body diagrams for these two blocks over here. Okay, so if you consider this block only, if you consider block of mass 4 kg, let's call it m1 only, and let's derive the formula and we'll memorize that formula. Okay, if in case you haven't seen this formula. Okay, so now clearly this mass is bigger, so the system will move like this. Okay, there will be acceleration. That means 6 kg mass, it will move downwards with some acceleration a. 4 kg mass will move upwards. So let's suppose this is m1, this is m2, and m2 moves downwards with acceleration a, and m1 moves what? Upwards with the same acceleration because they are connected. Okay. So what are the forces acting on m1? One force is the tension in the string, which will act towards the rigid support, and another force is what? Its weight, which will act downwards. So mg acts downwards, tension acts upwards, and what is the net force? So net force will be upwards because it is accelerating upwards. So acceleration is a, so net force must be what? M times a. So for this one, you can write m times a is equal to total upward force T minus total downwards force mg. Okay, so you got this one equation from the first part of the system. Okay, from first free body diagram. So you got m into a equals to, okay, it is m1. Okay, first mass we are calling it m1. m1 into a equals to T minus m1 into g. So let's suppose this is equation 1. Now let's write similar equation for second mass. So this is second mass. There are two forces acting on it. m2 into g is acting downwards. Tension in the string, because it is the same string, the tension in it will be identical. Okay, so T is same. Okay, so tension in the string acts upwards, and this one accelerates downwards with acceleration a. So that means net force is downwards. So how much is the net force? Net force will be m2 into a, okay, because its mass is m2 into a, and that should be equal to what? Total downward force, which is m2 into g, minus total upwards force. What is that? Tension in the string. Okay, so this is your equation number 2. And now what will you do? So you will add 1 and 2. So I am adding 1 and 2. So what will be my resultant? So on left hand side, you can see it's m1 into a plus m2 into a. Okay, so it's m1 times a plus m2 times a on LHS. On RHS, you have plus t and minus t over here. So when you add them, it gets cancelled out. Okay, then you have m2 into g minus m1 into g. Okay, and then you can take g common from this side, and you can take a common from this side. So if I take g common from right hand side, a common from left hand side, what do I get? So what do I get is, I get m1 plus m2 into a is equal to, it's equal to m2 minus m1 into g. So I get formula for acceleration. It is m2 minus m1 divided by m1 plus m2 or m2 plus m1 into g. And we have to memorize this formula. Okay, so this is the basic formula. This type of system is known as Atwood's machine. Okay, it is known as Atwood's machine, and we have to memorize the formula for Atwood's machine because it keeps on coming. Okay, so what is acceleration? Acceleration of this system is equal to what? It is the bigger mass minus the smaller mass divided by sum of two masses multiplied by g. Okay, so this is a simple way to memorize this formula. So let's substitute values. What is bigger mass? It's 6. Smaller mass is 4. And then g is, let's suppose it's 10. Or do we have to substitute? No. G is there in all the options, so we don't have to substitute for g. So it is 6 minus 4 divided by 6 plus 4 times g. So 6 minus 4 is 2. Okay, 6 plus 4 is 10. So 2 by 10, or you can say it's 1 by 5 times g. So this is the answer. Let's check. So option C is the answer. Okay, is it clear? Yeah, is it clear? Good. So let's move on to the next problem. The next problem is a block of mass m. So this is the block of mass m is placed on a smooth inclined wedge ABC. This is the inclined wedge of inclination theta. So theta is the inclination. Okay, as shown in this figure. The wedge is given an acceleration a towards right. So it is given an acceleration a towards right. The relation between a and theta, the relation between this a and theta for the block to remain stationary on the wedge is. Okay, so block should remain stationary. Why would it remain stationary? Because as this wedge is moved towards right, what happens? The block will be pressed against the wedge. Okay, so it will force a pseudo force in opposite direction to that of what? Acceleration. Okay, so that because this acceleration, there will be some normal reaction. Some normal reaction will be produced. Okay, and now there will be some normal reaction. So one component of that normal reaction, it will balance the weight of this object. Okay, so let's see how. So let's suppose we have this block. This is the wedge, and we have this block over here. So N, the normal reaction always acts perpendicular to the surface. So N is the normal reaction. This angle is theta. Mg acts downwards. So now how much will be this angle? So this angle is 90 minus theta, right? So this angle is 90 minus theta, and therefore what will be this angle? So again, this is 90 degrees over here. So 90 minus theta can be subtracted from 90. So if we do that, this angle again will be theta. Okay, you got it? How does this angle comes out to be theta? This angle is theta. Okay, the inclination of wedge is theta. Then this angle over here is this angle 90 minus this angle. Okay, so this angle is 90 minus theta, and okay, this angle is 90 degrees. Normal reaction is perpendicular to the surface. So 90 minus theta gives us theta. Okay, so that's why this angle will be theta. So what we'll do is we'll resolve the normal reaction along two components. So one component will be horizontal, one is the vertical component. This is n sine theta, and component along this direction. Yeah, hi Asma. So component in horizontal direction is n cos of theta. Okay, and now since the acceleration is towards right, what you can say is this block experiences a pseudo force towards left. Okay, so it experiences what? It experiences a pseudo force towards left. I will denote it by red. Okay, and I will write it as Fp. What is Fp? So Fp is the pseudo force. Okay, so now you can say that one component of normal reaction balances the weight. Okay, so that means, sorry, N is equal to mg. So not N, it's component in vertical direction. What's that? N sine theta is equal to mg and n cos theta balances the pseudo force Fp. And how much would be the pseudo force? Just like in circular motion, centrifugal force is the pseudo force whose magnitude is equal to what? Centripetal force. Okay, so it is equal to the real force acting, but it is felt in opposite direction. So what is the real force which is acting on this mass? So it will be towards this direction. Okay, and that real force will be its mass times acceleration, right? So the pseudo force will be equal to what? Just opposite to that, right? So it's acting in opposite direction, but its magnitude will be equal. So it is m times a. That's n cos theta. Now if you divide these two, this is 1, this is 2. So if you divide first by second, what do you get? Mm gets cancelled, nn gets cancelled. So g upon a is sin theta upon cos theta, tan theta. So 1 divided by 2 gives me tan theta equals to g divided by a, right? Okay, it should be. So you take a, so a is equal to g divided by tan of theta. Okay, did I miss something? Let's check it, because there is an option where we have tan theta, but it is a equals to g tan theta. So let's check. Okay, so you have this normal reaction and you resolve it along two components. One component is n cos theta. I'm checking. Okay, so this angle should be theta. Should it be theta? So this angle will be theta. Oh no. Okay, my mistake. Totally my mistake. I'm really sorry. So let's talk about these angles and I will clear it. Okay, you have this angle. You have this another angle. Okay, and you have a line like this. Okay, so you have two parallel lines and an intercept. So if this angle is theta, how much should be this angle? This angle should be equal to theta again. Okay, because we have two parallel lines and an intercept. So these are alternate angles. Okay, between two parallel lines. So this angle is theta. So this is the normal reaction in this direction. So this total angle is 90 degrees and this angle is theta. So how much should be this angle? It should be 90 minus theta and not the theta. Okay, so yeah, my mistake. It should be 90 minus theta and not theta. So what I can do is, if this is 90 minus theta, so I will fix it real quick. So this angle is not theta, it is 90 minus theta. But if this is 90 minus theta, that means this angle should be equal to theta. And then we can resolve n in two components. Okay. So this component through the angle will be n cos theta and away from angle will be sin theta. So basically sin theta and cos theta will get changed. Okay, it gets reversed. So now vertical component is n cos theta and horizontal component is n sin theta. Okay, sorry for the mistake. So vertical component is what? It is n cos theta and horizontal component will be n cos theta, horizontal component will be n sin theta. All right, and then if you divide first by second, now I will divide second by first. Second by first I will do. So what do I get? Because there is tan theta in the options, I will do second divided by first, and what do I get is, I get tan theta should be equal to what? So if I divide this by this, on left hand side you have n sin theta upon n cos theta, and on right hand side you have ma upon mg. Okay. Okay, I'm sorry, your name is Amsa. Sorry. Yeah, so it will be a upon g and not g upon a. All right, and therefore a should be g times tan theta. If you take that g on the other side, it should be a times tan of, it should be g times tan of theta. All right, so option D is the answer. And sorry for very silly mistake which consumed a lot of time. Okay, yeah, but I hope now it should be clear. So yes, any questions you can ask, otherwise we'll move on to the next problem. No questions? So let's move on to next problem, and the next problem is two blocks A and B. There are these two blocks A and B of masses 3m and m respectively. So their masses are 3m and m respectively, are connected by a massless and inextensible spring. It should be, okay, string they are saying, so massless and inextensible string. The whole system is suspended by a massless spring also. Okay, so now we have spring also. Okay, which is shown in the figure. The magnitudes of acceleration of A and B immediately after the string is cut, not spring, we cut the string. Okay, so when the string is cut, what will happen? How much will be the acceleration? This is the question. So let us try to solve this. So what are the important topics for NEET? Okay, so I would say, yeah, so most important topics are, so your first part of 11th standard. Okay, then from there you can take oscillations and waves is an important topic, and thermodynamics is an important topic. Okay, so properties of solids and liquids, they are not that important. And then from 12th standard everything is important. Okay, I hope you got it. So first part of your 11th standard, it is the base. Okay, then from second part, oscillations and waves and thermodynamics, these are the important topics. Okay, and then in from 12th, so communication systems, not communication systems, electromagnetic waves. There can be one question, there may not be a question, so you can, if you like, you can skip that. Okay, and first part, remaining chapters, they are very important. Okay, so you can say if you wait 11th and 12th standard, 12th is more important, but first part of 11th and oscillations and waves, and also the thermodynamics. How to get 180 out of 180? So to get 180 out of 180, this is not the time to start. Basically, in which standard you are, 11th or 12th? 12th. So you are appearing for NEET. So actually your all concepts should be clear, and so you should not be looking for the important topics. Okay, so every topic should be clear to you, and you should practice a lot on all topics. Okay, yeah, so let's try to solve this problem. So this problem, let's draw free body diagrams of these two systems. Yeah, welcome. So let's draw free body diagrams of these two components of the system. So if you draw free body diagram for mass B, I will just draw it here. Simple. Its weight acts downwards. It is mg. And there will be tension in the string which acts upwards. So now from this free body diagram, what can you find out? T is equal to mg. Okay. Then now if you talk about A, this was B. So for A, this is A. There is some net force due to its weight, which is 3 mg, plus there is also tension in the string acting downwards. Okay, because it has to support weight of B also. So it is 3 mg plus mg acting downwards. And what will be now? The upward force. So due to this weight, the spring gets extended. Okay, so there will be some displacement in the spring. So let's suppose it is x, and there will be restoring force generated in the opposite direction to that of displacement. So restoring force is in upwards direction. Okay, so that is force in the spring. And how much is the magnitude of that? Some spring constant k multiplied by x. Okay, so from this one we can write kx, the spring force, is equal to what? Or we need not also write kx over here. I can just write the spring force is equal to total downwards force if the system is steady. So it is 3 mg plus mg, that is 4 mg. Okay, now if you cut this string from here, what will happen? So all of a sudden tension will become zero. Okay, if you cut the string, what will happen? Tension in the string will become zero, because now there are no weights to be supported. Okay, so when string is cut, you can say T becomes zero. Okay, now if you talk about B, what force will be there? So for B, there is only one force, that is the gravitational force, because the other one was tension in the string, and net force is mg minus T, and since T becomes zero, okay, T equals to zero, so it is just mg. Okay, so how much will be its acceleration? So acceleration is equal to force upon mass, and that's equal to g. So for B, the acceleration is what? It is force upon mass, and it's equal to g. What about A? So for A, we have now, this is A. So its weight is acting downwards. String is cut. So tension in the string was downwards. And you have this force due to the spring which is acting upwards. Okay. So what will be net force? So net force, I can say net force on A is equal to net upward force is Fs minus net downwards force, it is mg, okay, plus T, but T is 0, not mg. Its mass is how much? It is 3 mg, not mg, it is 3 mg, right? So it is, its weight is 3m, sorry, its mass is 3m, so weight is 3 mg. Okay, so net force will be what? The total upward force minus total downwards force. Total upwards force is spring force, total downwards force is what? Its weight, which is 3 mg, plus the tension in the string. But tension in the string, when you cut the string, will become what? 0. So this term becomes 0. Okay, so Fs minus 3 mg, and earlier we found out that Fs is what? It is 4 mg. So let's substitute that. So it is 4 mg minus 3 mg, and this is equal to its mass times acceleration. How much is its mass? 3m. Acceleration is a, suppose. Okay, so force is mass times acceleration. So on right hand side we get 4 mg minus 3 mg, it's mg, and m gets cancelled out. Okay, So we can write, or let's write, mg is equal to 3 times ma. Now cancel out m and take 3 on other side. So you get acceleration of A equals to what? G upon 3. So when string is cut, acceleration of B is G and acceleration of A is G by 3. So what should be the option? It should be option A, because it is asked accelerations of A and B respectively. So for A it is G by 3, for B it is G. Okay, this is not correct. Okay, so here it's given in reverse order. So this one is correct. Okay, option A. So is it clear? Yes? Okay. So let's move on to next problem. So next problem is a balloon with mass m is descending down with an acceleration a. Okay. There is a balloon and the balloon has got some mass m and it is descending down with acceleration a. So how much mass should be removed from it? How much mass should be removed from the balloon so that it starts moving up with acceleration a? So this is a nice question from NEET 2014. So we have a balloon, something like this. Okay. So there will be two forces acting on this balloon. So what is first force? So first force is its weight, which acts downwards. And second force is what? The upthrust due to the air. Okay. Due to which its acceleration will be lesser than the other bodies. Right. So normally if there was no air, the acceleration could be what? G. Okay, which we take in the normal cases. But here it's balloon, so it will experience some upthrust due to the air, and that is considerable. Okay, so that upthrust, let's denote it by force due to air. It's upwards and it is descending down with acceleration a, where a is less than g. So since it is descending down with acceleration a, so net force will be what? Net force should be downwards. Okay, so in this first case, net force is downwards, and suppose it is F net, it should be equal to what? Total downwards force minus total upwards force. Okay, so total downwards force minus total upwards force. And it can be written as m into a equals to mg minus force due to air. So let's call it equation number 1. And now what we do is we remove some mass from this balloon. Okay, so let's suppose there was some person inside the balloon. There were 2 people, 3 people, I don't know. So you remove some mass, you remove somebody. Okay, so what will happen? So such that it moves upwards. When you remove somebody, it starts moving upwards. Okay, with same acceleration a. So now net force should be in what direction? So in this case, let's suppose the mass is m minus something, m dash, and force due to air is same because it depends on the area of the balloon, and its weight now it will be m minus m dash multiplied by g. But now it moves upwards with acceleration a. So in this case, F net will be equal to what? Total upwards force, which is force due to air, minus total downwards force, which is m minus m dash times g. Okay, and this net force in the second case can be written as what? Mass times acceleration. So let's write that. So net force will be what? Mass now has reduced from m to m minus m dash. So it is m minus m dash into A, and it's equal to force due to air minus force due to air minus the weight. Okay, m minus m dash into g. So this is your equation 2. Now what will you do? You will add 1 and 2. Okay, so let's add 1 and 2. And why am I adding these two? Because in one, force due to air is negative, and in second one, force due to air is positive. Okay, so if you add them, it will get cancelled out. Okay, so I will do 1 plus 2. So 1 plus 2 will give me what? So in first one, it is m into a, m into a. From second one, I have m minus m prime into a, and that's equal to, on right hand side we have mg from first one, mg minus m prime into g, and we want to solve for m prime, so let's simplify this. So we have m into a plus, if we multiply this, we will have m into a from this term, m into a minus, we have m prime into a from this term, so it is m prime times a, and it's equal to mg minus, so from here we have m into g, mg, okay, minus minus plus, it is m prime times g. Okay, see this, from this one you have m times g, and this minus and minus becomes plus, so plus m prime times g. Okay, and then mg and mg gets cancelled out, so this gets cancelled out. Okay, and you have to find this m prime, so you take m prime on left hand side and m on the right hand side, so it is 2 times of m into a. We can take on, or let's take this on right hand side, because this is positive here, so 2 times ma equals to what? It is m prime into g plus m prime into a. So I have taken this thing on right hand side. Okay, so you can take m prime common from the right hand side, and you will be left with what? G plus a, and on left hand side you have 2 times m into a. And now let's take g plus a on the left. So what do you get? You get m prime equals to this 2 times ma, and g plus a will come in denominator, so it is 2 times ma divided by g plus a. So this is the answer. Okay, so is it clear? Yes, is it clear? All right, so let's move on to the next problem. And next problem is, now we have 3 blocks, not 2 blocks. Okay, so 3 blocks with masses m, 2m and 3m are connected by strings as shown in the figure. After an upward force F is applied on block M, the masses move upwards with constant speed v. Okay, masses move upwards with constant speed v. What is the net force on block of mass 2m? Okay, so masses move upwards with constant speed v when you exert a net upward force F. So question is, what is the net force on the block of mass 2m? So this is the question. So anybody can answer this? I will wait. This is a straightforward question. So it's good if you can answer this. No answers? Should be option C. Yeah, very good, Dev. It's because, see, when you exert force F, what happens? It balances the force due to gravity, and therefore the masses move with constant speed. So if all masses are moving with constant speed, what should happen? If all masses are moving with constant speed, that means net force on each of them is equal to 0. Okay, because if there were some force, then there could be some acceleration, right? So there is no acceleration, that means the force is 0, and they've answered it very correctly. So option C is the answer. Okay, so yeah, very good. So this was very simple from NEET 2013. So this type of question should be asked, right? Okay, let's move on to the next problem. Next problem is, a person of mass 60 kg is inside a lift of mass 940 kg and presses the button on the control panel. Okay, so he presses some button on the control panel. The lift starts moving upwards with acceleration 1 meters per second square. Okay, G equals to 10 meter per second squared. The tension in the supporting cable is. So this is a straightforward question. You have this lift, there is a person inside the lift, and the lift is supported by a cable. Okay, so there will be some tension in that cable, due to which what happens? Lift moves upwards with some acceleration, or lift moves downwards. Okay, there is total weight of this person and the lift. So that's what we have to consider. Let's suppose it is M. So total weight is M. What will be M? It is weight of the person. Okay, mass of the person plus mass of the lift. So it is 60 kg is mass of person, and 940 kg, it is 60 plus 940. So that means it is 1000 kgs, right? So that is total mass. So total weight is M times G, which is acting downwards, and it's given that the lift is moving upwards with acceleration 1 meters per second square. So let's suppose acceleration is A. Okay, so now acceleration is upwards, that means the upward force is dominating the downwards force. Upwards force is greater than the downwards force, right? So we can say the net force must be upwards. So it is total upward force minus total downwards force, that is tension minus mg. And yes, so we want to find out tension, so we can move mg on the other side. But before that, what will be net upward force? It will be equal to m into a, mass into total mass multiplied by acceleration. And now let's move mg on the other side. So we get ma plus mg is equal to tension. Or you can take m common, so it is a plus g. Okay, what is mass? As we have found it out, 1000 kgs. What is acceleration? It's 1 meters per second squared. Okay, so 1 plus 10 is 11. 11 times 1000 is 11,000. So 11,000 newtons should be the answer. So it is option C. Okay, very straightforward, very simple question. Okay, but it takes some time. All right, so then let's move to the next problem. Again, it is based upon a lift. The mass of lift is 2000 kgs. When the tension in the supporting cable is 28,000 newtons, then the acceleration is. Now it is very similar to the previous question. So we have a lift. Okay, there is no man or woman inside a lift. So mass of lift is something, its weight will act downwards, mg. There will be tension in the string which acts upwards. Okay, and then we are given with the value of tension, and the question is what will be acceleration in this case. Okay, then the unit acceleration is, okay, so let's suppose it accelerates upwards. All right, so if we are correct with the direction, our answer will turn out to be positive. If we are wrong, then answer will turn out to be negative. Does not matter. Okay, in any case we'll come we will come to know what's the answer. So let's suppose acceleration is a in upwards direction. Okay, so net force will be what? It will be an upwards direction, so which is equal to tension minus mg, because net force is upwards, so it should be upwards force minus downwards force, and it is, oh, I wrote ENT here, ear, nose, throat. Okay, ENT surgeons, you are going to be doctors, right? So NET. Okay, so net force is upwards, m times a is the net upwards force, and it is tension minus mg, and we are asked what will be acceleration, so we can take m on the other side, so a is equal to t minus mg divided by m. Now we just have to substitute the values, so it is 28,000 newtons minus mass is 2000. Okay, then g is 10, so it is 20,000. Oh, using red pen. 20,000 divided by how much is mass? 2000. So 28,000 minus 20,000 is 8,000. 8,000 divided by 2,000 is 4,000, and it's positive. Sorry, not 4,000, it is 4. Okay, 4 meters per second square, and it is positive. So it means it is moving what? In upwards direction, right? Okay, so direction that we considered is correct. If it was negative, then it means that the direction we considered is wrong and it has to be in downwards direction. Okay, but here direction we considered is correct because it turned out to be positive. So it is 4 meter per second squared, and there are both the options are there. Okay, that's why it is important. So 4 meters per second squared upwards, not downwards. Okay, so another simple problem this was. So let's move on to the next problem. Okay, a man weighs 80 kg. He stands on weighing scale in a lift. Okay, another lift, and which is moving upwards with uniform acceleration of 5 meters per second squared. What would be the reading on the scale? This is the question. Okay, now let's talk about this man who is inside the lift, but he is standing on a weighing scale. Okay, so now what are the forces acting on the man? So for this man, he is not connected by any string or something. Okay, he is not connected by any wire. The lift is connected by wire. He is standing on the floor of lift, not floor. There is a weighing scale. He is standing on that. So what is the weight? It's the normal reaction. So there will be a normal reaction acting upwards, and mg, the force due to gravity, will be acting downwards. Okay, so what would be the reading on the scale? So it's given that this system is accelerating upwards with, let's say, acceleration a. It is given to be 5 meters per second squared, but let's suppose it is a. What are the forces acting on the person? The normal reaction and the acceleration, sorry, the force due to gravity, mg. I'm not calling it weight because there is a weighing machine which will show the reading equal to what? The normal reaction acting on the person. Okay, so now since the net force is upwards, F net is upwards, the total upwards force must be greater than total downward force, so N is greater than mg. Okay, so net force is N minus mg. All right, so what is net force? It is is mass times acceleration. It is n minus mg. Take mg on the other side. So you get n is equal to ma plus mg. You can take m common. So it is m times a plus g. Okay. And you can substitute values now. So it is 80 multiplied by a is how much? It is 5 meters per second squared, plus g is 10. So 10 plus 5 is 15. 15 times 80. 15 8s are 120. So 1200 newtons. Option D should be the answer. Yeah. Okay. Is it clear? All right. Let's see another problem. So another problem is a lift of mass 1000 kg which is moving with acceleration 1 meter. Another lift, okay, it is moving with acceleration 1 meters per second square in upwards direction. Then the tension developed in the string which is connected to the lift is. We solved very exactly similar problem. Okay, so let's consider lift. Tension acts upwards, it accelerates upwards, that means net force is upwards. Weight acts downwards. Okay, so the net force can be written as what? Total upward force minus total downwards force. So it is m into a is equal to T minus mg. You can take mg on the other side. So you get T equals to ma plus mg. You can take m common. So it is m times a plus g. And how much is that? So a is acceleration is 1 meter per second squared. Okay. So 1 plus g is 10. How much is mass? 1000. Okay. So 1000 times 1 plus 10, that's 11. So answer should be 11,000. Oh, there is a problem because this 10,800 is also present. So if you take g equals to 9.8, we have tendency to take g equals to 10 for simplicity, but it can lead to a problem in this problem, right? It is 9.8. So 9.8 plus 1 is 10.8. 10.8 times 1000 is 10,800 and that is the answer. Okay, so T is equal to what? 10,800. So tells us that we should look at the answers, all the options first before confirming that G is indeed equal to what? 9.10. Okay, so for simplicity we take it to be equal to 10, but uh, there can be some option where it's 9.8, okay, which is calculated using 9.8. All right, so let's move on to another problem. So this is a problem based on Atwood's machine that we have seen earlier. Okay, we derived the formula for it earlier. Two masses as shown in the figure are suspended from massless pulley. Then the acceleration of the system when the masses are left free is, what will be acceleration? So we have solved it and we have found out the formula in one of the earlier problems. So I will directly write down that formula. So what is acceleration of Atwood's machine? It is m2 minus m1 divided by m2 plus m1 multiplied by g. And what is m1 and m2? m2 is the greater mass, m1 is smaller mass. So acceleration will be in direction of the weight acting on the greater mass, that is 10 grams over here. So it is 10 minus smaller mass is 5 divided by 10 plus 5 times g. Okay, we are not converting it in SI units because what? The units will get cancelled out. So 10 minus 5 is 5, 10 plus 5 is 15, it is 5 divided by 15. So that's 1 by 3. Okay, so answer is G by 3. Option B is the answer. Okay, so it's very simple, and as I told earlier, we should memorize this formula for the Atwood's machine. Okay, acceleration of Atwood's machine is equal to what? The greater mass minus the smaller mass, m2 minus m1 divided by sum of the masses. Okay, or you can say difference of masses divided by sum of the masses multiplied by g. Okay, it's very simple. Yeah, and we finished all the problems that we wanted to cover today. So that's it for this class. If you have any questions, you can ask me. Otherwise, let's end it here.